Today we are going to complete the reaction time lab where we convert measurements of distance into time using a physics formula and our spreadsheets. So the first thing we're going to want to do is take our measurements that we would have done during the class time activity and enter those values here. So for example, we had 17 centimeters, 18 centimeters, 21 centimeters for the first person. Maybe the second person was a little bit slower in catching it, so 23, 27, and 26. Our next person we'll say was similar, closer to the first one, 19, 19, and then one really quick one. And then we'll enter the data for our last person, who is a little bit more all over the place. 24 and 20. So you'll notice that when I entered this, it automatically converted the distance from centimeters to meters. And the reason we want to do that is because the standard unit of measurement for distance in physics is the meter. So it automatically converted the first two. What we need to do is convert that last measurement. So if we're not sure what the formula is, we can look here and look in our formula bar, and we see that it gives us, it's referring to the cell next to it divided by 100. So we could probably go in here and say equals the cell next to it divided by 100, just like that. And there we go. It converts it to 21.21 meters, and we have an automatic average calculation here, which converts it into time. So now let's go ahead and do that for the second person. You'll notice that for the second person, it doesn't convert any of the distances from centimeters to meters. We need to do that, but luckily we just learned how. So let's go ahead and do that again. 23 divided by 100. And since it's the same idea, I can actually copy this and paste it into all the cells, and it will automatically update for each of those. Now the next thing is I need to figure out this formula, because this is not being automatically calculated anymore, whereas it was up here. So I see, if I look again at the formula bar, I see it says equals sum D3 to D5, that's these cells immediately above, divided by the count D3 to D5. So in other words, it's looking at what these add up to and then dividing it by how many values I actually had. And that is the literal definition of the average function. So let's go ahead and do that. We'll go ahead and say equals sum of these, close parentheses, divided by count of those. And there we go. So if I were to just do this real quick, you'll see that if I do count and then I select these, it's going to tell me that the count is 3 because there are 3 values. So, alright, looks like person 2 is done. It went ahead and automatically converted each of those distances into times and calculated the average time. So now we're ready to move on to person 3. We can go ahead and enter these formulas that we used previously into these cells here. So again, equals this divided by 100. Copy that, paste it down. Remember this formula, so equals sum of the, oops, don't need that right now, of the values above. See, those add up to 0.53 divided by count of those same number of cells, which is 3. Enter, we get an average of 18. Now we have to enter a new formula which converts the distance into time. So to figure this out, again, we saw that in the previous two people's sections, it actually computed it automatically. So we can take a look at those formulas up here in the formula bar, and we can try and replicate that here. So we see it's equals square root of 2 times whatever this cell is, whatever's in this cell, divided by 9.8, as in 9.8 meters per second squared. So let's go ahead and go equals SQRT, whoops, SQRT. And if we're not sure what needs to go in here, it'll tell us the value. So we said 2 times whatever is over here, divided by 9.8. And then we can go ahead and close parentheses. We see we get 0.20, which is kind of in the same ballpark as what we were seeing previously. So it's likely we did it correct. And if we want to practice, we can go ahead and enter that again, or we can simply copy and paste this all the way down. And this last one, for average time, you'll notice previously we actually just calculated the square root of the average distance. So let's go ahead and do that again here. Equals SQRT, 2 times average distance divided by 9.8. Oops, I didn't close parentheses, but it's smart enough to do that automatically for us. All right, lastly, let's go ahead and move on to person 4. We can actually just copy all of these and paste those in, and you'll see it automatically updates for the new location. Let's practice this one more time. Square root of 2 times this value divided by 9.8. And this is why we actually like using these cell references, because if I were to actually type in 0.17, I wouldn't be able to just copy and paste this formula into these cells. I'd actually have to manually enter it every single time. All right, lastly, we got average time. Let's look at the formula. You can probably guess it's similar to this one, but it turns out there's actually another way of doing it. And for those of you thinking, why isn't there just an average formula? Well, there actually is. So we can actually say equals average and select the values we want the average of, close parentheses, and there you have it. You see that's about in line with what we're expecting at 0.20 seconds. So now we're ready to move on to the next section, where what we're going to want to do is we're going to want to enter the values for the various, if this were a class, we'd enter the values for all of the people in the class. So let's start with the average distance drop. So if we look back over here at our calculations, we got 0.19, 0.25, 0.18, and 0.20. All right. Now, one thing we're going to notice real quick is that while these 3 values are to 2 decimal places, this one's only to 1. So let's go ahead and take a moment to adjust the number type. We'll adjust the format. Instead of it being automatic, let's go ahead and change it to number. So now they should all be to 2 decimal places. Also, because I don't have the data points for all of these other people, we're going to go ahead and just use some hypothetical data using random number generators. So we see we've got rand between, that's one we're going to use. Low number 5 to 45, and because we want it to be a decimal, let's go ahead and divide that by 100, and that gives us a random value between 0.05 and 0.45 and 0.45. So let's go ahead and copy that, paste that all the way down. So now we've got a whole bunch of random values that are within the range that we're expecting to work with. Reaction time, let's go ahead and use that formula again. Square root of 2 times this value divided by 9.8. Enter. Now you'll notice some of these values updated automatically. That's because random number generators will generate a new random number every time you make a change to the spreadsheet. So let's go ahead, now that we have this formula, again let's make this all to just 2 decimal places. You can always also adjust it if you want more or less. Let's go ahead and copy that and paste that all the way down. Now we see we've got a reaction time in seconds for all of the people in this group. If I look over here, I've also got some formulas where I've got the max value. So the slowest person had a reaction time of 0.3. The fastest person had a reaction time of 0.1 second. The median reaction time was 0.2, and the mean or average was about 0.22. And you'll notice that, again, if you look up in the formula bar, those formulas are pretty much exactly what you'd expect. Equals max, equals min, equals median, equals average. And next up, what we can do is we could try and see if there's actually a correlation between some given characteristic about our participants and their reaction time. For example, one might hypothesize that taller people have faster reaction times than shorter people. Well, we can actually test that. We could take all of these values. If we knew what their height was, we could record their heights here, and then we could put their average reaction time here. With some values now in these columns, we can see the average reaction time is calculated. We can even enter an alternative formula, average of this column, and we should get approximately the same. It's already formatted to 2 decimal places. As we look at the graph, we can see it's also updated to see if we could determine a correlation. Now what's really important here is adding this equation of the line and our squared value. So to do that, what we do is we go here, select our 2 columns, and then we say insert chart. And there's our chart. And then we're going to move this to its own sheet. so it's easier to work with, and say edit. Now what's really important is we want to make sure that we have a scatter plot. So if you don't have a scatter plot, it might default to another type of graph. Just go ahead and select that. Then go over to customize. And there's a couple things that we can do here. You can change the chart style. You can change the titles of the axis. So for example, maybe I want this to be called ReactionTimeLab. And you'll see it updates there. You can also do this for your horizontal and vertical axes, but those look pretty good for now. The most important thing that I want to introduce is how to add that trend line and the R-squared value. So you click on series, scroll down, select the box next to trend line, and then you'll see you get even more options. You can scroll down here and click show R-squared value. So now, we also want to say that the label uses the equation. So now we've got the equation of our line, y equals mx plus b form, and our R-squared value. So that's how you can do a graph of the data that you collected in your ReactionTimeLab, all using Google Sheets. So once you're done, you're ready to have your students share. Hope you enjoyed.